Okay, today we're going to continue with slope, but we're going to talk about it as a rate of change. So please make sure you have your name written at the top here. Um, and we're going to just jump right into exercise one. So it says points A, B, and C are shown on the graph below. Calculate the slope for each of the following line segments. Write your answer in reduced form. Okay, so your slope can be found by doing rise over run. So that's 1, 2, 3 up and 2 over. So your slope, which is m, equals 3 over 2. From B to C, we're going to go up, and then we're going to make a right here. And we went up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So that's 6 over 4, which is equal to 3 over 2. And the third one is AC, which we're going to go up, and then we go over. So if I count up, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6. 9 over 6. If I divide by 3 on the top and the bottom, I get a 3 over 2. So I have 3 different line segments, and I have the same slope. So let's take notice of that. It's asking you now on part B to place point D on any point. All right, here's D. Right there. Okay, and now without calculation, what is the slope of AD? Well, I'd venture to guess it's 3 over 2. And they're asking for an explanation. Well, what happens is any 2 points on the same line will have the same slope as any other 2 points. Okay, so you can take any point with any other point on the same line and you will always get the same slope. So I guess we should write that. You can use any 2 points on the same line and you will always get the same slope. And this is because this is a linear relationship where the rate of change is constant, okay? Constant rate of change, which is the same as saying constant slope, the same slope. Okay, so we can see from this exercise that any 2 points along the line can be used to calculate the slope or the rate of change of the line. This is true for all sets of 2 variables that are linearly related. And that just means forms a graph of a line. So this is really important, that we get this kind of thing. True for any 2 sets. Oh, that's supposed to be a highlighter. Just highlight that section. Okay. All right, exercise 2. It says the following graphs show Raquel's distance from home as she drives to college. So as time goes by, she's getting further away from home. Okay, so time is your x and y is going to be your distance. Determine the slope of this linear relationship using the slope formula and the 2 points that are shown. Okay, so we have an x and a y. Change that. And we have an x and a y. And if you recall, the slope formula is y2 minus y1 over x2 minus x1, which is the same as rise over run. Okay, so we are going to fill in some values. We're going to use 348 minus 116. I guess I should put a 2 and a 2, and that'll be a 1 and a 1 then. Over, and our x values are 6 minus 2. When I subtract those, I will get calculator. Oh, I did it already. It's going to be 232 or negative 232. Nope. Depends on which way you put them in. But you're going to get a positive or a negative, doesn't matter. Okay, so it's going to be 232. 6 minus 2 would be 4. And you're going to get, when you divide, I think you could divide it by 4 and get 58. And that would be over 1. So I'm reducing or dividing by 4 on the top and the bottom. Ah, that's supposed to be divided by 4. E. Okay, so that's just a reduced fraction. You can always use math enter in your calculator also. All right, what are the units of the slope? Well, let's see, what were we talking about? The change in y, so the y values are the distance. And the x values are the time. So it's 58 miles per hour. Oop, per hour. What does the slope represent? It represents the rate at which she's traveling. Okay. All right, let's keep moving along here. So slope as rate of change. Well, it means the change in your dependent, which is just your y values, over the change in your independent, which is your x values, and that's that formula, y2 minus y1, the change in y over the change in x, which represents the rate of change. Okay, we're going to continue on to exercise 3, so if you're not there, turn the page. It says Hachi was driving a car at a constant speed on the New York State Thruway. He noticed that after driving 1 hour, he had 12 gallons of gas left. All right, so I'm assuming this is going to be important. And also this word constant speed, that's important. Then after driving for a total of 3 hours, he had 8 gallons of gas left. So after 3 hours, he had 8 gallons of gas left. Assume in this problem that there is a linear relationship between the amount of gasoline left and the time Hachi has been driving. Express the information given in this problem as two ordered pairs, where the independent variable, independent is your x value, is time, and your dependent variable, your y variable, is gallons of gas. Okay, so our ordered pair are x comma y. In the first case, it's 1 comma 12. Time versus hours. And in the second one, it's 3 hours, and they had 8 gallons left. Okay, so that's that. Secondly, it says calculate the slope of the line connecting these 2 points. Include units in your answer. So I'm going to ask you to pause and use the slope formula. I'll write it for you here. So you're going to plug those 2 numbers in and you're going to calculate that, and hopefully we'll have the same answer when you come back. Okay, you should have gotten a negative 2 over 1, and I just did it both ways. 12 minus 8 over 1 minus 3, 8 minus 12 over 3 minus 1. It doesn't matter which way your x1 and y1 and all that stuff goes. What matters is that you make sure your signs are correct at the end. Okay, so include units in your answer. That's the only thing I left out. So the unit should be hours and gallons, right? So the gallons was the y. So it's gallons per hour. All right. So they're decreasing 2 gallons per hour. The rate of change is 2 gallons or negative 2 gallons per hour. All right, so how long after he started driving will Hachi run out of gasoline? Well, let's see. He had been driving for an hour and he had 12 gallons left, right? So at 1 hour, he had 12 gallons left. Oh, what does this look like? At 2 hours, well, if he's losing 2 gallons per hour, he had 10. 3, he had 8. We already knew that. 4, he had 6. 5 hours, he had lost another 2 gallons. That would be down to 4. 6, he had 2. 7, he had 0. So it took him 7 hours. Okay, so that's one way to look at it, and I'm sure we're going to see another. Let's keep going. Over the time interval given, calculate the rate of change for each variable. Include units in your answer. Okay, so let's see. We have 3 weeks old. A corn plant is 4 inches tall, and at 15 weeks old, it's 46 inches tall. So we can do rate of change by the slope formula. So we have an x and a y. We have 3 weeks old and 4 inches tall. And then we have 15 weeks old and we have 46 inches tall. Okay, so we're just going to find the slope of these two, these points. So we could do 46 minus 4 over 15 minus 3. That's going to give you a 42 over 12. If I divide by 12 on the top and the bottom, I will not get a 1. So let's see what we can do here. What we can do is divide by 12. Let me get my calculator here. And I get 42 divided by 12. And I get 3.5. I'll take it. All right, so let's see. 3.5. Lost my pen. 3.5. What is that talking about? Our y value, inches per week. Okay, that's the rate of change. 3.5 inches per week. I'm going to ask you to do this one on your own, and I'll get you an answer, but stop and do it on your own. Okay, so you should have gotten 54 miles per hour. If you reduce, you have this 162. Check that out. Make sure you have all your numbers right. And we're going to keep going. So, unit conversions. One extremely important skill for both mathematics and science is the ability to change from one set of units to another. All of these changes are done by multiplying by the rate that one unit changes compared to another. So in this case, the space shuttle can fly at a speed of 25,000 feet in 1 second. How many times faster does the space shuttle fly compared to a car going 55 miles per hour? All right, so we have here 25,000 feet is to 1 second. And then they talk about 55 miles is to 1 hour. Use that fact that 1 mile is 5280. I think I'm going to leave this for us to do tomorrow. Yeah, we'll do that tomorrow. So, moving right along. What's next? Nothing. We're done. Hey, that's great. So, hopefully you got all this. If you did not understand something, please go back, look at the notes again. But basically, you're using the slope formula. You're using the slope formula here, and you are just finding the rate of change, which is just basically unit rate. Okay, that's it. You're done.